Welcome to my 32nd episode on collections. In the last, we talked about one of the very important factors. Let me go back and show you what was I talking about. Is that we talked about stream operations, and the stream operations we talked about how to use distinct in streams, to remove the duplicates. Now as we go through these collections, there is one more important aspect we need to talk here is that uh, the important aspect is about boxing and auto boxing. Now the question comes here is that why do we need to talk about boxing and auto boxing when we are already in the middle of we finish collections and we have come to the streams part, and why should we talk of boxing and auto boxing? Let's take a very simple example here, right? Like let's make a copy of this. Uh, Copy, and let's call this as auto boxing example to boxing. Uh, in the auto boxing, what we are going to do is very simple things here. Uh, as usual, we're going to call public static void main here, and we will be dealing with something known as integer here. And when we deal with integers, we are you have to note here that we are dealing with the integer object. We are not dealing with the primitive integer. Now the question comes here is that this is generics, right? And in the generics, if I'm making a list, I'm making a list of not type integer, but type integer object. What happens if I say here as integer yes equals 10? Okay. Uh, I am, putting the number 10 in an integer object. Is this okay to do this way? Or should I do this? Integer yes equals 1 equals integer dot value of it. Then I say this 20. But now let's forget this and let's try to print this. System dot or dot println will try to print yes. Also will try to print yes one. What's going to happen? Let's see. Let's run this. And when you run this, what are you expecting? Okay, let's write this value as 20. Okay. So what are you expecting? Let's run this and see. Okay, yes is 10, yes 1 is 20. So the question comes here is that instead of doing this integer dot value of, what if I say yes equals directly 20? Will it work? What is it? Insert. It is already there. Okay. Now let's run this. Okay, in both the cases it is running, it is printing the value. So even if I am giving a primitive int here, like primitive int is declared as int I equals 10, right? And let's say I equals 30. Let's try to print this. Plus I, let's work. What do you say? Will it work, not work? Let's see. Uh, what if I take a primitive int, it also prints. If I take object, also it is taking the primitive into 10, number 10. If I declare 30 into a primitive int and try to print, it prints, which is fine. Now I am assigning a number 10 to a object integer, yes. And that is also printing 10. And earlier I had written this as integer dot value of 20. This also works. So when this works, what is the need for me to say integer dot value of 20, right? Int I is equal to 30 prints. Integer s is equal to prints. Integer s1 is equal to integer dot value of 20 prints. But understand this, that when we talk of collections, we have generics in collection to say the type of list. I can have a list, I can leave the generics as it is, which we talked about in our first example, uh, where we were uh, adding this string, and this is also string. No, this is not string. We are just adding, we did not say what type it is. So we do not declare what type it is. You know that by default it becomes an object. So that is why we are able to print this. But since we are not mentioning any generics, by default it is an object. Here, if we have to mention generics, the generics always, remember, a very important point is that generics always refers to class interface or enum. It cannot refer to primitive types like primitive character or primitive integer. Now the question comes here is that if it cannot take primitive integers, how will I store those primitive integers inside the list? I will have to do this every time, like integer dot value of whatever is the input given to me, or can I do this? This was also working. So let's take this and understand one at a time. If I print a primitive int, it is printing, but how come it is working in this way? In this case, this is an object. So internally, what is happening is that this is fine. I'm doing an integer dot value of, because it is, you see this, it returns an integer instance representing the specified int value. If a new integer instance is not required, this method should generally be based preference to constructor integer int, as this method is likely to yield significantly better space and time performance by caching frequently requested values. So what I am doing here is that I'm taking integer dot int value of. But here I'm not doing anything. But still it takes this 10 and prints this 10. So internally what is happening is when you give this, the compiler itself will make this as if it is appearing like integer dot value of 10 during compile time. And this is called as autoboxing. Autoboxing simply means that you are wrapping a primitive int inside an object. That's called as autoboxing. That means if the compiler does for you, that is called as auto, that is automatically happening. But here you are doing it manually. That means you are, you know, making the primitive int a part of this object integer. So you're manually boxing. This is automatically boxed. Now what it has to do with generics? Now that's a question you will have. Remember this, the very important question here is that when we are dealing with collections, like list is one of the collections, and list can store a generic object or it can store, you know, a non-generic object. So let's do one thing is source format, and then when I say this is integer, I'm going to add. It's not going to accept this. The method add nature is type of list is not applicable for argument strings. So it is not applicable for argument string. That means I can store numbers inside this. 1, 2, then 3, then 4. Then what I'm going to do is I'm simply going to make a stream, do not filter anything. So I added this to the stream of type integer. Then I'm calling mylist.stream dot for each I. I'm just going to print each element of the stream. So far so good. We have an issue here. Lambda expression cannot redeclare another local variable defined in the enclosing scope. Okay, so it's complaining about this. Now let's see what is going to happen. What I am doing here, uh, I am just declaring an array list. Array list should be parameterized. Why? It's not necessary. This is not needed, and by default it understands this, but just to come out of the complaint what Eclipse is doing, I have come out of this. See, now I'm adding primitive integers here. Compile time, there is no complaint. It says, okay, let's see what it is going to print now. So it is printing 1, 2, 3, 4. That means it accepted a primitive integer and then converted to the integer object because my list of generates is int. Would this be allowed? Can I do something like this? What does it say? Insert dimensions to complete reference time. Okay, if I say int s, no. So it does not accept primitive time. It keeps on complaining and complaining about dimensions. So that is why I need to make this of type integer. Remember this, the very important point here is that uh, that the generics, in generics always refers to a class or an interface or enums. I'll later take an example, but for this now you need to understand this basic concept that the boxing, auto boxing happens here. And when you're printing, the unboxing happens here. It converts this to a primitive int when you're, you know, uh, printing this. You can print object also, but understanding autoboxing is very important here. So autoboxing is needed when we use generics in collections like list. And in this episode, I just want to cover it and make it very short. So just to summarize our concepts, what is autoboxing? Autoboxing is a technique used, we can also use, right? It's a technique used by Java compiler to convert a primitive value to its wrapper counterpart, which is important. So autoboxing is possible here because compiler understands that the object integer is a wrapper for the primitive int. That's why it can do it automatically. It's not going to, when you add number, it's not going to auto box to a float, right? You're just adding number one to the, or not to string. It is automatically going to auto box to an integer. So that is what is very important. We need to understand. When an int value is assigned to an integer wrapper, compiler automatically converts to the int value to an object without any need to explicitly cast the int value or by calling any method to convert into an integer object. So remember this, that we don't need a casting here. So here, the second example, we are doing an explicit casting, right? That is not needed. When the explicit casting is done automatically or by the compiler, we call that as an autoboxing. So this is what we learned about autoboxing. And we need to understand, very important part here is generics is only for classes, interfaces, and enums. So if you bring in primitive ends, there has to be an autoboxing. Otherwise, if the compiler did not convert this or did not do autoboxing, then this would not have been possible for us. So this is the concept at which I want to stop here. If you like this, subscribe my channel, hit a like button. Thank you.